but I do want everyone to know I'm now going into my fourth year of being.
Just see the videos. If anybody knows sign language, maybe we'll just have somebody sign it out when we get to the videos. If we got any volunteers for that? Yeah? All right. Well, thank you for coming to your training today, even though I'm sure it was probably not optional. But I got to say, I appreciate y'all being here to learn about weather. Yes, you do need to sign in because from what I understand, if you don't get signed in and there's no proof you attended, then you have to go up to the 4-hour remedial version. Isn't that how it worked, Jenny? Okay. How many of you have not been to one of these Storm Fury classes before? Do we have any newbies in the crowd? A couple. Either the rest of you are veterans or you don't want to admit it because you're afraid you'll get called on. No? Well, the history of that, just for the benefit of those who are new or those who maybe forgot what this is all about or why we're here. What this program is it's called Storm Fury on the Plains. And it's something the National Weather Service does on an annual basis. They do the basic presentation. They actually will go around and they'll present it one time in every county, and then they will hand the presentation off to us to go ahead and redeliver it. I will tell you that if you do go to one of the National Weather Service versions of this presentation, mine may just be a hair different. I may take a little bit of creative liberties. They didn't put it in a non-editable fashion when they gave it to me. So I kind of tweak it a little bit, make some changes, rearrange some stuff. So if you see any of the NWS guys, just tell them, yeah, I saw exactly what you guys put out. Yeah. The history behind this stuff is many, 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 many years ago, the National Weather Service started doing these severe weather trainings and targeting them largely toward people who are storm spotters. So folks out there specifically going after the weather and calling in storm reports, whether to 911, to media stations, to the National Weather Service. So it's been lovingly called storm spotter training all these years. Now they realized really early on that there's a need in the public as well to learn about severe storms. Whether you intend to be out there tangling with them or you just accidentally end out there tangling with them, you need to know what's going on to keep yourself safe. Either just knowing that I need to get out of the path of it or being able to read a storm to tell if it's dangerous or not or if it's heading toward you or not. So this information has now been tweaked over the years to be targeted both to folks that are spotting formally and those folks who just want to learn more about weather. It generally follows kind of a formula. We'll do some pieces on how to storm spot. We'll do some pieces on storm science, so how storms put together. And then there's always a safety section too, just kind of those general pointers of when do I take shelter, when do I not, that kind of thing. They do tweak the presentation from year to year, put new videos in, put new slides, new information. And every year the theme kind of changes a little bit. And I will tell you that this year it sort of swerved back toward the storm spotter bent, but not exactly storm spotter specific. What they're really pushing this year is just the value of getting information from out in the field anywhere, whether it's a formal spotter or just a member of the public that sees something in the sky and goes, that just looks wrong, I got to tell somebody about it. How important all that ground truth information is to what the National Weather Service does. So what they're focusing on this year is building those partnerships between the National Weather Service, the broadcast media, and then everybody else who's out there seeing the weather and impacted by the weather. That communication piece is, okay, you've seen something, and it looks bad, and probably somebody should know about it. Now what do you do with that information? Who do you tell? How do you communicate that? And then the building trust factor is, if the National Weather Service gets a report of something bad happening, or if we get a report of something bad happening, if we know the folks that are calling us, or if they know the folks that are calling them, there's a relationship there, so they're better able to trust the information flowing in. Because believe it or not, there are some people out there that on a blue sky day when there's not a cloud in sight will call in and go, I saw a tornado. Nah, you didn't, but yeah, thanks, appreciate you. So there is a measure of added credibility to weather reports that come in if it's from somebody that we know. And of course, we want y'all to be safe. So a big focus of these is always on the safety piece. Do we have severe weather in Kansas? Do we have severe weather in South Central Kansas? I mean, lately it felt like we were having the winter that wouldn't end, and then for a few days it was the rain that would never end. And I hope we don't move into the severe storms that never end, but do we generally get some severe weather? Now, it feels like we've been on some dry spells lately, hasn't it? We've had a couple years where things have been down a little bit. If you look at the numbers there, what the National Weather Service received last year in terms of severe wind, hail, and flooding reports was a total of 297 reports in Wichita Weather's coverage area. Now, that was compared to 406 reports, individual reports, the year before. So last year was kind of a dry year, and so that may make people feel a little complacent that, storms aren't so bad, we don't get weather here. Tornadoes-wise, we had 20 tornadoes in Wichita Weather's coverage area. We actually did have a few of those in Butler County last year. And of course, the strongest one would be Greenwood County's tornado, the one that went through Eureka, because Eureka is apparently on the every other year plan right now, and I really hope for their sake they're not. But there were some large hailstones. Barton County recorded their largest was 4 inches back in May. And then there was some strong wind, 87 miles per hour recorded in Rice County in July. And the counties that recorded the most weather reports last year were Cali and Sedgwick. I don't know if you heard the one night that Cali County actually recorded 9 tornado touchdowns, which is a record that we are not trying to duplicate here. So there was some weather last year, but it was not necessarily a great big weather year. Now, I don't know if any of you have been watching what AccuWeather's been putting out or some of those other weather forecasters or doom and gloomers, but they're all saying that we may be in for a more active season this year than normal. You never know till we get there, but just be aware that that's what they're saying. That might be kind of small from where you guys are sitting. But if you're wondering about do we really get that much weather? Do we really get that many tornadoes? The National Weather Service pulled records from 1950 to 2016, so about a 60-year time period, and said, well, where did the tornadoes end up in their coverage area? And as you can see, every single one of those little pins was a tornado. Some were in their coverage area. More specifically, if you look at Butler County, these were the tornado touchdowns that were recorded during that period. The little pin is the tornado rating, and as you can see, a whole lot of them are EF0. So we had quite a few tornadoes recorded. Most of them are really little tornadoes. But there is a really big black line that maybe means a little more to you guys than other people in the county. Anybody know what that big black line represents? Yeah, the 91 Andover tornado. So every once in a while we get a bigger one. We've got I think we've got a few EF2s and EF3s recorded in there as well. But on the average, when we do get tornadoes, they're usually little, but there's never a guarantee. And in terms of where our tornado season fell last year, really, there's no consistency in our pattern of tornadoes. You see it kind of goes up and down across the Weather Service's coverage area. We have some high years, we have some low years, but actually on average it's about 20 tornadoes a year. So last year, believe it or not, actually was an average year, even though it felt a little bit lean. Now if you look at the counties that reported tornadoes, again, really tiny print, but Butler County you'll see is the 4th one over at a count of 84 tornadoes recorded from 1950 to 2018. When you're looking at those numbers, it's kind of hard to say, do we just get more tornadoes than everybody else in this area? Or is it because we're the biggest county, so we have lots more places for tornadoes to touch down? Or do we just have that amazing of spotters that they catch the tornadoes and they relay the information back? Or is it a combination of all of that? Yeah, it could be all of the above. But we're definitely higher up on the scale of the number of recorded tornadoes in NWS Wichita's history. Well, some things that the National Weather Service would like us to point out. Before we really get into the meat of the presentation, they want us to talk a little bit about what they do over there and give a few pleas for mercy to remember that forecasting is not an exact science, as you guys have probably figured out if you follow any kind of weather reports at all. Well, first of all, they do admit there will be times that a tornado will touch down without a warning. And there will be times that hailstones will fall and there's no severe thunderstorm warning issued. Or there may be times that there will be high winds all of a sudden ahead of any warnings being issued. Yeah, it does happen. Well, what we did looking back at some figures, over the last 10 years, in their coverage area, 248 tornadoes were reported. 211 of them occurred when there were tornado warnings in place, which means 37 times a tornado hit before a warning hit, which does sound a little nerve-wracking, doesn't it? Except if you look at the fact that 34 of those were in EF0. So at least they're not missing the big ones. They don't blink and, oops, there was an EF4, sorry. And really, as National Weather Service offices go, they'd like to point out that they're really high up there on the accuracy level. This is a comparison of all the National Weather Service offices that actually are in tornado areas. To compare apples to apples, they didn't pick Weather Service offices that never issue tornado warnings. But in those offices that issue a pretty substantial number of tornado warnings, they are actually the second most accurate office. I think they said it was Grand Forks, North Dakota that took #1 spot. But they're the second most accurate office in terms of their warnings actually playing out. They hit the tornado warning when there actually is going to be a tornado and when it develops. Way over the other edge is the National Weather Service average for tornado detection. So if you're going to live anywhere, this is the coverage area to be in, apparently. And it really is their goal to not get caught with their pants down and not get caught where a tornado hits before a warning hits. But they do point out that it's a partnership. They're going to need our help in order to make that happen. So they can work harder to make sure that they're reading their radars right, they're reading their instrumentation right, they're getting that information flowing correctly, and understanding when the environment's right for a tornado. But they really do want a partnership with us as well, because the stuff that our folks are seeing live and in person, looking at the sky, really does make a difference in how they work with their data and how they issue their warnings. But first, a little side bent. They'd like me to talk about that forecasting thing and show you just really how difficult forecasting is. It's not like it shows up there. That's not actually a dartboard. So what they do is, first they have to do a whole bunch of math. How many of you love math? A few people? Well, they have to figure out, basically they're trying to figure out what the atmosphere is going to do. So first of all, they have to find out the mass of the atmosphere. So they do some math. Then they have to do some conversions of that math. And then they have to do some more conversions, because what they're trying to do is figure out how many molecules are in the atmosphere, because we're trying to figure out what those molecules are up to. So after doing all of their calculations, they've come up with this figure, that there are approximately 1.09 tredecillion molecules in our Earth's atmosphere. So you just learned a new number, I think. I don't know how many of you have heard of tredecillion before. And you learned a new fact, 1.09 tredecillion molecules. Well, that's for the whole Earth, so that's not really relevant to us. So let's start scaling it down. Well, Kansas is still a little too big, or the Earth is too big, so let's scale it down to Kansas. In Kansas, where we've got about 82,300, let's say, square miles of air, well, if you take that 1.09 tredecillion molecules and put that over just Kansas's square mileage, that means there's 45.5 duodecillion molecules that our National Weather Service forecasters are responsible for keeping track of. So they're trying to figure out what all those molecules are doing. So like this, a little mercy on their part if every once in a while one of them kind of goes, gets a skew from them. So when they are actually making forecast decisions and warning decisions, they're really not studying each of those individual molecules to figure out what's going on. But they are doing a three-part process, where they are taking three pieces of information in particular, and they're doing a 2 out of 3 thing most of the time. They're looking at what their radar tells them. So does the radar show signs that something nasty is developing? They're looking at the environment. Is there something about today's environment that just seems like it's ripe for really big tornadoes or really big hail or really high winds? And then they're looking at what are the reports flowing in from the field. Is there something that's saying that, yeah, everything they're looking at is panning out and this weather's really happening? Well, if 2 out of those 3 tell them that something bad is a-brewing, then they'll probably issue the warning. But in all honesty, sometimes all it takes is a 1 out of 3. If there's something screaming on radar that just says, "Ugh, really big tornado, really big hail," something nasty like that, they may just go ahead with that warning. And sometimes that 1 out of 3 is you guys. A trusted person out in the field looks up at the sky and goes, "Ah!" and reports that back to them. And that may be just enough for them to issue that warning. I see something spinning, I see something lowering, this is not going to be a good day, and boom, you get a tornado warning. So be aware that the information that you provide may be that tipping point that causes that warning to happen. Why does the National Weather Service need eyes in the sky? Because these guys have a lot of just crazily advanced instrumentation. They've got a lot of education. They know weather way better than we know weather. So why do they really need somebody out in the field relaying information to them? Well, I will tell you that when you're looking at radar, radar tells you a good story about what could be happening or what is likely happening, but can't necessarily tell you for sure this is what is happening out there. It may look on radar like, yeah, there is probably a really big tornado forming, but it can't say for sure. Or it looks like there may be some really substantial hail coming out of this storm, but it can't say for sure. Or it looks like really high wind being produced. But as soon as somebody out in the field takes a look at that cloud, takes a look at that storm, they can give some real ground truth information, can't they? So if the Weather Service is looking at a storm and thinking, yeah, that looks like a ping pong ball-sized hail sort of storm, and then guys from Andover Fire get on the radio and tell me, we got pea-sized hail falling in Andover. We relay that to the National Weather Service, and I'm like, oh. So it may look nasty on radar, but maybe this thing really isn't worthy of a severe thunderstorm warning. So that, putting those two pieces together, what they see on radar with what you guys see live and in person, really helps them get a good picture of what's going on and get a lot more credibility to their warnings. So if you saw this, all right, so you're the one looking at this storm. You're the one filming this. How many of you are saying, that's a tornado? How many of you are saying, it's in the process of becoming a tornado soon? How many of you think it deserves a tornado warning? Yeah? Well, at that point, based on radar information, that had a severe thunderstorm warning on it, not a tornado warning. Because what the National Weather Service was seeing on radar did not look tornadic at all. But what is the guy with eyes on the storm seeing? Yeah, and you heard him say a couple different times, that thing's on the ground. So yeah, that was only a severe thunderstorm warned storm. And we'll talk more about that one later. Now here's one thing that also impacts the National Weather Service and another reason why they really need people with eyes on the storm. And it has to do with their radars. So the way a radar functions is you got your nice little radar site, which the closest one to us is at the Wichita Weather Service office down by the Wichita Airport. And that thing's shooting out radar beams. And those radar beams are going out and they're bouncing off stuff and they're bouncing back to the radar site. And the radar site says, okay, I see stuff out there. Maybe rain, maybe hail, maybe flocks of pigeons, but I'm bouncing off of something. Now, as that radar beam goes out, it kind of goes like this. And the curve of the earth does this. So the further and further and further you get away from that radar site, especially when you're dealing with a storm, the higher and higher and higher up you're actually hitting the storm. So what we really care about is what's going on down here, because that's where the tornadoes are coming out, that's where all the bad stuff is landing on us. But as soon as you get 60 miles, 80 miles, or 100 miles away from a radar site, you're slicing way up here in the storm. Okay, can tell you some information maybe about the strength of the storm, if it's spinning, stuff like that. But you really lose that view of what's going on down here way by the ground. So if you're in a community that's 100 miles from a radar site, is the National Weather Service really getting a clear view of what's happening to your community? Not so much, right? Well, there are a few radar sites in Kansas. And there is a lot of overlap between those radar sites. We're actually in a really good spot right here. If you look at the weather radar, the Wichita Weather Service radar loops, or the ranges, you can see that right here where we're at, we're pretty much in that first ring. So if you look back at this guy, come back. We're kind of in that 20-mile, that almost at the bottom of the storm slice. So we're in a really good spot here. Now let's say instead you were clear up here in Marion or further out like in Council Grove, where suddenly you're way out and you're hitting the storm at 8,400 feet instead of 1,300 feet. The information they're getting from radar that far out is just not as clear as they would like. Now there's other options. If you get to the point where you're so far out from a radar site you're no longer getting good data, one solution is switch to another radar site. And we actually do have another option closer to us. If ever the Wichita radar site goes down, one of the ones that we'll default to is down at Vance Air Force Base, down below the state line. Downside is now look at this area here. We're suddenly slicing a storm at about 8,500 feet. It still gives us a picture of weather, but not really a very clear picture of what's going on down at the ground. So then it becomes increasingly important that we've got eyes down on the ground saying, here's what's actually going on in this storm. Recognize this picture from what we saw earlier? The guy says, yeah, that thing looks like it's on the ground. This is what another person was seeing at the exact same time from a slightly different vantage point. How many of you call that a tornado now? Kind of looks like it's in contact with the ground, right? Now keep in mind that tornadoes don't always look filled in all the way down because it kind of depends on how much stuff that they're sucking up into them to color them. But I definitely see clouds at the top and clouds at the bottom, so probably would call that a tornado. In fact, definitely would call that a tornado. And remember, that was only a severe thunderstorm warned storm. Anybody have any idea what storm that was? Yes, that was the Eureka tornado. That was the viewpoint they were seeing while it was still a severe thunderstorm warned storm. The people with eyes on the storm realized what was going on. They saw a tornado forming. The National Weather Service saw a severe thunderstorm. How important was it for the people that were looking at the storm to tell the Weather Service what they were seeing, or tell somebody what they were seeing? Desperately important? Yeah. Do you think that folks today, just general citizens, understand that they do play a role in that whole warning process? Or do you think most folks are thinking, I take this picture, I tweet it to Cake, and my picture might end up on TV, and I can go, hey, that was my picture. There may be some of that going on too. But really, people nowadays on the ground are a huge part of the warning process. They just don't necessarily know it. If you are going to report, whether it's to us, to our department, whether it's to the 911 center, you're telling Becky, whether or not it's to Cake, whether it's to the National Weather Service, there's some things that you need to relay rather than just, ah! I mean, that's helpful too. We understand sense of urgency, but first of all, by going through this class, all of you are now officially going to be trained spotters. You can call in and say, hi, I'm a trained spotter, and I have a weather report. And then that adds just a little bit of weight to what you're about to say. And also if you're affiliated with somebody like, hey, I'm Andover Fire, you know, that just levels it up even more, right? All right, then we need to know specifically what you are seeing, not just a whole bunch of rain, really big hail, really high winds, because I don't really know what your standards are. So if you can kind of quantify it somehow, I've got baseball-sized hail. I've got estimated 60-mile-per-hour winds. I've got a wedge-shaped tornado moving toward the city. Things like that, as specific as you can get. You know, share that kind of information rather than just, you know, dogs and cats. Well, if the dogs and cats are flying, note that too. And then where are you specifically in relation to a town? If you say I'm at Aunt Martha's house at the corner of Bob's Road and Doug's Road, and I may know where that is if you're in the county. The National Weather Service definitely won't know where that's at. So if you could kind of say I'm 2 miles east of Andover or 3 miles south of Rose Hill or something like that, giving a relation to a town always helps. And then when did it occur? Is this a delayed report? Are you calling this in after you took shelter and it actually happened 20 minutes ago? So that's important as well. And is it something that lasted a while? So was it sustained? You know, it was just dumping buckets of hail for 5 minutes straight. Was the tornado on the ground for 2 minutes and then it lifted? But kind of the duration of the event too. How many of you use Twitter? Any tweeters here? Yeah. We're trying to get into the Twitter thing. We've got all of 70 whole followers on our Twitter feed right now. So if you want to, it's Butler EMA_Kansas. You want to go out there and just do like a mercy like or something. But NWS Wichita is definitely getting into Twitter. And they would really like people to tweet them information because they love pictures. So if you want to tweet information, you can go ahead and tweet it over either ours or theirs or both. They also pointed out that hashtagging, if you do the hashtag KSWX, anybody in the state of Kansas interested in weather is probably following that hashtag. And then if you want to put stuff on Facebook, you can do that as well. Facebook is a lot less monitored during severe weather, so your picture or your report might not be seen until the day after. Twitter is really what the Weather Service prefers, and I know the media outlets really follow Twitter. And this is an example of a good report. 1 mile southwest of Eureka, the tornado's on the ground and it's moving to the northeast. They like that kind of report. If you want to use just good old-fashioned phones, the National Weather Service does have a 24-hour 1-800 line that they'll take storm reports at, so you can always call them directly. I also included our hotline. You can call us if you're public safety and you have the EMA Ops channel on your radio, which public safety should all have. You can holler at us on EMA Ops on the 800 radios. You can call our office. Now that is our office number. That's not my 24-hour cell phone number. So if it's 2 o'clock in the morning and it's a real low-end storm that's dropping dime-sized hail and you try to call and tell me that at that phone number, probably nobody's going to pick up. But if it's a big event and it's 2 a.m., I'll probably answer. And then you can always call your 911 center locally here. It's you guys would probably prefer the non-emergency number for the most part, right? Unless it's a giant tornado eating the town again, then Becky won't mind if you call 911. But if it's just, hey, I've got quarter-size hail, she probably doesn't want you tying up 911 for that. But you can call and relay reports to them, and they'll relay them to us as well. So that is the spotter portion of it. And we will go back again a little later to the importance of people telling information and sharing information. But now we're going to move on to the storm science portion of it. Before we move on, any questions about what we've covered so far? All good? Y'all look so thrilled. Huh? Yeah, absolutely. Well, it's after lunch. At least it's not Monday, but yeah. So what we're going to move on to now is that storm science. We're going to start talking about how storms get put together, and we're going to look at what does all of this mean. So if you see all this stuff, you're out driving around and you come across something like this, is it bad? Do you need to do something about it? Is it something to worry about, and what does it mean? And we will just a little bit talk about some radar stuff. Not quite as much this year as to what all this good stuff means. So the first and foremost important thing when you're dealing with weather, probably the biggest thing you probably want to identify first is the updraft. An updraft is basically the point of the storm where it's feeding itself. Doesn't matter if it's a big storm, little storm, supercell, squall line, no matter what kind of storm it is, the storm has to feed itself because as soon as it stops feeding, the storm dies. So knowing where it's feeding or where it's gathering its fuel is a very important part in telling you where the danger part of the storm is. When it comes to fuel, storms like warm, moist air. That's what feeds a storm. You know those times when the National Weather Service is doing that doom and gloom for days and days, and it's going to be pandemonium, and we're going to have these monstrous storms, and there's going to be this outbreak and these massive tornadoes, and then the day starts, and it's gray, and it's cool, and nothing happens? Draw all that buildup. Well, what ended up happening in those cases was we didn't get the fuel. It started out gray, it started out overcast. We didn't heat up our atmosphere. It didn't get that nice instability and that buoyancy, and so there was nothing to feed a storm. So we need warm, we need moist, and we need that stuff to get kicked in the air. Now, some of our storms, you'll notice they'll pop up, they might drop a little hail, drop a little wind, and then they're done. They don't amount to much. Our little single-cell storms. What's going on with these guys is they're feeding themselves, and they're sucking all this warm, moist air up into the air, but they're sucking it up straight in a vertical line. What comes out of a storm besides tornadoes? What comes down? Rain comes down, hail comes down. Is that stuff warm? Not generally, right? So you've got all this warm and moist you're trying to suck up into a storm to feed it, and then you got all this cold rain and cold hail, and since it's all going up here and coming down here in the exact same space, the storm basically short circuits itself out, and it can't survive. It can't last, and so storm collapses, maybe a little further on, it finds a little more pocket of fuel, pops up again, and then it dies. You see a lot of these during this July time frame. They sometimes call them popcorn storms. They'll just up and they're down, and they're up and they're down. Because they don't hang out long, they don't get big enough to create really large hail, really large tornadoes. Severity-wise, they don't get too bad, but what we do have a problem with these guys is sometimes when they go ahead and short circuit, so they've been sucking that air up, and then the cold comes down and short circuits it, is that storm can collapse and release a whole lot of strong winds. So high winds is probably one of our bigger concerns with these guys than really large hail or really large tornadoes. Now, if you look at this guy versus that one, right away, does he look a little more intimidating? Something you don't want to tangle with? So our supercell thunderstorms, those guys, especially this time of year, that mid-March to about mid-June, we get really concerned about those. They do the same thing in that they're sucking warm, moist air up in them. That's how they're feeding. However, they're doing something a little bit differently. And that, we're going to jump ahead just for a second. What's going on a lot of times in the spring is that down here at this level, we have a certain wind speed. The higher and higher you get up into the atmosphere, the more the wind speed is increasing. So it may be like in this example, 30 miles per hour at the base. Clear up in the atmosphere, it's 100 mile per hour winds. So as that warm, moist air rises, it actually starts to get pushed over like this. So instead of having an updraft or a feeding area that's going straight up, our updraft is feeding this way. And at an angle, it feeds, and then the rain and hail gets dropped out over here. And we get this nice little circuit going. And it can sustain itself. And it can keep going and keep getting bigger, which means bigger hail, stronger winds, larger tornadoes, more ferocious storms. That's how these guys manage to last as long as they do, which means that higher severe potential. We're more concerned with what these guys are going to put out. Now, do you notice that kind of weird striping to him? He almost looks a little like a barbershop pole in a way. Another thing with these really massive storms, the longer they live, the more cranked up they can get to where that entire storm, that entire updraft column starts rotating. So if you're standing under it, which I hope none of you would be standing under it, you may see that entire storm doing a rotation above you. Does not mean you have a giant tornado about to drop on your head. It also means it's not a spot you want to be. Sign of a really bad storm. All right. So in this case, what you're seeing here is you've got this nice clear area, and that actually is the bottom of your updraft, or the bottom of where that storm is feeding. And because it's feeding up at a slant and dropping rain and hail out ahead of it, that means your dark area right there is actually the front of the storm, sucking up, dropping rain and hail ahead of it. So that's your updraft area, and that's your downdraft area. And because meteorologists are really clever when they name things, this rain-free area is called a rain-free base. So, who knew, right? All right, so a little aside, we're going to go to another kind of storm just for a second here. The squall line is constructed very differently than a supercell. But like I said, every storm has to feed itself. So this guy has an updraft. It just doesn't look very much like a supercell's updraft. When we're talking a squall line, this is that horizon to horizon, that big long line of a storm. If you look at it on radar, you see this long, long line of reds and yellows and stuff, not that just little blob of storm. What's happening with this guy is the updraft is actually at the front. Because what's happening is this storm is marching along, big, long line of a storm, and it's sending out this big wave of cold air ahead of it. It's pushing cold air out and acting like a scoop shovel and scooping warm air up the front of it. So you see right here, cold wind darting out the front of the storm, warm air getting scooped up the front of the storm. So it's feeding at the front, and it kind of looks like a snowplow. Just going along and plowing warm air up into it. That's also what creates this really weird phenomenon, that shelf cloud, which is where your updraft is in a squall line storm. So that's where it's feeding, right at the front. Kind of look familiar, that radar picture? Long line of a storm. What we're concerned with these guys, because it's doing that pushing out of that cold air ahead of it, that big thrust of wind trying to feed itself, what we're concerned about is wind. Strong straight line wind with this storm. They can also create a whole lot of rain. Sometimes they create tornadoes along that front edge. Not really those great big tornadoes. They're not going to create the EF4s, the EF5s. Where you're going to want to watch out for, though, is right along that leading edge of the storm. That's where that strong straight line wind is going to happen. And looking at the updraft on a picture, it's that kind of ribbon of bacon marching toward you. It's right where that shelf cloud typically is. One of the things you have to watch out for, because wind is the risk with these with these squall line storms, is sometimes the wind gets really strong. There are times that at one point in the middle of the storm, the winds that are shoving this storm along, suddenly there becomes a nice little slippery slope. One pocket of wind finds a nice little place to slide down and give the storm a big punch from the back. So right where it's giving that punch, the storm starts to accelerate. And it's just at that one spot, which means the storm starts to do this, and it starts to bow out. And at that bowing point, so in this case it'd be right in here, at that bowing point, the wind speeds that are pushing out ahead of the storm are accelerating as well. So while the rest of the storm maybe is producing 40 or 50 mile per hour winds, that bowing point, potentially 70, 80, 90 mile per hour winds. So if you're looking at radar, or in this case, you can actually see the way the storm's arcing as it's approaching. If it's starting to bow out, it's losing that nice line look and doing a this, don't be at the bow. Bad place to be. All right, let's go on vacation. How many of you are boaters, like to be on the lake? Anybody? How many of you check the forecast before you get on the boat? All right, I'd like to see that. It's 6:30 in the evening, and you're about to go boating. Now, when you check the radar and you check the forecast, you see this off in the distance. It's about 30 miles out. You're like, well, what do you think? Should we get on the boat? Should we not get on the boat?
Don't get on the boat.
Don't get on the boat? All right, class is over. You can leave. Good answer. All right, so probably not getting in the boat. 2 minutes later, they actually issue a severe thunderstorm warning on this storm. Does that kind of cement your idea you should not get on the boat? Yeah. Well, about half an hour later, the storm's starting to look like this. It's now only 10 miles away. And it kind of has that long squall line sort of look on it, at it. So squall lines, we're worried about what kind of hazards? Strong straight line winds. Really shouldn't get on the boat, right? So we're expecting to see some wind, right? But we've got a 10-mile cushion here between us and the storm. Maybe a quick trip. Go out, come back. No? Well, this little bluish-green line right here is actually something you might see on radar when you have a squall line approaching you. And what it is that's the edge of the wind. As that wind goes shoving out ahead of the storm, you can see a little bluish-green line, depending on what your radar feed is that you're using, a little thin line ahead of the storm, which is that gust front, and where that wind is kicking stuff up ahead of the storm. So you may look like you've got a 10-mile buffer between you and the storm, but you don't have a 10-mile buffer between you and the wind. It's already here. How well can you read the map? Do you know where it's at? Yeah.
Shell Knob, not Branson, Shell Knob.
So this look familiar? don't think we can hear the video. But what the video is doing is it's recounting that tragedy that happened last year with the duck boat that tipped over or got submerged. And initially, I don't think the counts were this high, but what they ultimately came out with was that 17 died and 14 were injured. Now, we're not going to make any judgments at all about whether they should have been on the lake or not. But what happened was they got tangled with a storm that had high straight line winds on it. And that storm was warned when it hit them, when they were out on the lake. So being aware of your situation before you head out into a vulnerable position is extremely important. Because as you saw from that radar image, it wasn't the storm itself that got them into trouble. The storm wasn't even probably there yet when they got hit with that wind. If you know by looking on radar that, oh, I got a gust front approaching me, the storm's still miles away, but I know what that little ribbon means, and I can see that shelf cloud out in the distance, and I know I'm dealing with a squall line storm, and I know that squall line storms come with high straight line winds potentially, you can make decisions to keep yourself safe, right? Rough crowd. Well, now we're going to get a little deeper into specific storm features of our supercell storms. Because those are the ones we're really concerned about this time of year. These are the ones that have that really high potential of creating big hazards, big hail, big wind, heavy rain, potentially big tornadoes. So we're going to get a little more specific into how these storms are put together. We could do textbook style, or we could look at real storms and be a lot more interesting. So our plan is we're going to actually dissect the storm into two parts. We're going to divide it into upper level features and lower level features. Because here's the thing. There are certain parts of the storms that you can see when you're far away and certain parts that you can see when you're close up. And there are clues, depending on if you're far or close, there are clues that tell you if you're in trouble, if it's moving toward you or away from you, if it's a strong storm or if it's a weak storm. And by putting those clues together, hopefully you'll know where to go and when to go if you need to take shelter. So we're going to start far away, because my hope is the first time you tangle with that severe storm as it approaches is from the distance, when you still have plenty of time to make decisions and take action. So let's say you're 40, 50 miles away from the storm. You're looking out in the distance and you see these beautiful clouds starting to develop and bubble and percolate off in the distance. One of the things you want to look for first is the existence of an anvil cloud. What you're doing when you've got an anvil, remember we've got all that warm, moist air that's rising into the atmosphere, it's feeding the storm, and that updraft, the bigger it gets, the more warm, moist air it draws in, the longer it lives, the bigger the storm can get, right? Well, as that warm, moist air rises into the atmosphere, it's not going to go up forever. It's going to top out eventually. Eventually, it hits a layer of the atmosphere where it can't go any further. But it's got to do something. So typically what happens is it'll get all the way up there, and then the winds that are pushing that storm along just kind of push the top of that updraft column over. And then it starts to sprawl. And so it sprawls in the direction the storm is getting pushed. So as that anvil sprawls out, or that nice pancake flat top of your storm spreads out, it's actually kind of like a pointer. The storm's going that way. So you look at where the sprawl is going and go, okay, I'm here, anvil's sprawling that way, I'm in a good position. And one thing you can also look for too is, how substantial is that anvil? The guy on the left, does it look very intimidating? Kind of wispy, spun cotton, pretty little cloud sort of look. Yeah, he's not all that substantial. But this guy over here, big, thick, meaty anvil. He's probably got a big, thick, meaty updraft beneath him. So that gives you a gut feeling that that storm's probably a little more substantial. And there you can actually see, very sped up, they're usually not that fast, you can see the way that anvil is spreading out, telling you, storm's moving that way. Now you're going to think I'm a liar, because sometimes as you look at these anvils, they look like this. You go, okay, yeah, right. So I'm supposed to be using this to gauge which way the storm is going. Well, hopefully there should be one part of the anvil that's long and one that's a little shorter. Because what can happen is all that warm, moist air rising up into the atmosphere can be going up with so much power and so much force that when it hits that upper level of the atmosphere, instead of just all tipping over and cooperating nicely, sometimes it goes. That area where there's no rain going on is our rain-free base, which is the bottom of our updraft area. And really for a supercell, when we're talking about tornadoes, that's our action area. That's where we're concerned about it. So we're going to try to find specifically the rain-free base, and we're going to try to figure out what's going on under that rain-free base. So we found our updraft. That big column of air, all that stuff rising, creates a rain-free area. It's dropping rain and hail over here. Well, underneath that rain-free area, which is the bottom of our updraft, we're trying to see, is there stuff happening? Is there stuff dangling? More specifically, what we're trying to find out is this thing producing a wall cloud? Which a wall cloud is just a portion of that rain-free base that kind of lowers down. It may look something like that. And you may have traffic driving right under your wall cloud. When we're trying to determine if we are dealing with a wall cloud, some of the things we're looking at is, first of all, do I have a lowering beneath my rain-free base? Is it actually attached to my rain-free base, or can I see daylight between that dangler and the rest of my storm? And then, okay, I've got something dangling. It's attached to my storm. Is it hanging out, or did it come down, go up, come down, go up? And then, is it actually doing something? Can you tell that that thing's doing something? What is it doing? It's rotating, yeah. So what we're doing is we're progressing toward making a tornado. We're not doing any kind of guarantees. That doesn't mean this thing will, in the next 5 minutes, produce a tornado. But we're looking at, okay, found our rain-free area. Oop, we've got a lowering. That puts us a step toward a tornado. The lowering is hanging out. It's staying. It's solid. It's substantial. That puts us closer to a tornado. Oh, crud, it's not just hanging out. Now it's actually got an organized rotation, even closer to a tornado. So that guy, that's a very risky area to be right now. And I love it. People are just driving past it like it's no big deal. If that lowering is not connected to the base of the storm, and it's just kind of hanging out there, who knows what that little chunk of cloud is called? A SLC, or a scary-looking cloud. Because like I said, meteorologists are really clever when they name things. So if you see junk hanging under a supercell thunderstorm, and it's not connected to that storm, and it's not doing an organized rotation, it's just sort of doing this, probably nothing to worry about. It's probably just a scary-looking cloud. So here you can see that nice, clear structure. Definitely have our rain and hail over here, so your paint job concern is there. And then your rain-free area, your tornado concern is here, because that's the bottom of our updraft. And then all this little clutter and scud and stuff, that's not something we're worried about. Looking for that really, like this guy, that really solid, organized wall cloud with rotation. Now, what if you're looking at it live and you're looking at it on radar and you're trying to compare the two and figure out how those two relate to each other? A supercell thunderstorm can have a very distinctive look on radar. It can just be a blob and tell you nothing, or it can have a very distinct structure, like this one right here. That is a classic supercell thunderstorm structure. Now remember when I said a radar beam will shoot out, it'll try to run into something. When it runs into something, it bounces back to the radar site. That's what's called base reflectivity on a radar. Shoots out a beam, it hits something, it comes back. Like I said, could be rain, could be hail, could be dust, could be chickens. The more and more and more stuff that it hits and the more beams that bounce back, the darker and more concentrated the colors get. So when you see something like this, probably too much to be chickens. You can kind of assume it's a storm, right? And you'll notice how it gets from more spread out and lighter to more concentrated and dark. This section out here is actually pretty much the anvil portion of your storm. That's where the storm is sprawling. Not a lot's going on at the front of the storm, but then the further back in you get, all of a sudden you get really dark, concentrated, bullseye sort of look. So you know the radar beam's hitting a lot of stuff. So it's probably heavy stuff in a storm that comes out. I'm giving you as many hints as I can. Probably the heavy rain and hail, right? So your heavy concentration of rain and hail is going to be right here. So that's your downdraft section. So you got your storm that's growing at an angle and dropping rain and hail. So this is your downdraft section of your storm. But then we have this nice blank area where nothing's happening. So you got big rain and hail and then nothing right here. What do you suppose that area is? It's the rain-free base. And what is the big risk area of the rain-free base? What are we worried about under that area? The potential for tornadoes. So here you're going to get hammered with rain and hail. Here is where you need to watch out for that tornado potential. This is an especially cranked up supercell because you see how it kind of spins around the back there? That entire storm is doing a really significant rotation, and that's going to pull the little bit of it behind the back of that rain-free area. So you know you've got rotation. You know you've got a massive supercell. You've got a rain-free base area. So you probably have a pretty substantial storm there and a pretty high tornado risk in that kind of a storm. So right there, this heavy rain and hail area equates to that darker rain and hail area there. And then that rain-free area, I know it's kind of hard to see with the lighting, but your rain-free area matches your rain-free base there. So that's how it looks between what you see live and what you see on radar. Now there's one other little piece you kind of have to watch out for because we can't keep it simple. I mean, that would have been nice to just leave it like that. Okay, rain-free, get a wall cloud, you get a tornado, we're done. No, there's one other little thing we have to watch out for, and that thing's called the rear flank downdraft. What's going on here is you've got all that warm, moist air going up in the atmosphere, and we've got winds up here that are pushing our storm along, and they either push the storm or sometimes they break around the storm, but sometimes they also will go and slide down the back of that updraft column, just come plunging to the ground like it's a super slide. And as they come sliding down the backside of the storm, they can pick up some pretty good speed. They also have a tendency to kind of scour away a bit of the clouds as they come tearing down the back of that updraft column. So it may create a little horseshoe of light at the back of your rain-free area. Couple concerns there. First of all, you've got wind plunging to the ground at a good rate of speed. Never a good thing. So you've got that to tangle with. Other concern is sometimes that rear flank downdraft or that wind diving down the back of the storm can actually get sucked into the rotation of the storm. And sometimes that combination of that air descending, getting pulled back into the spin of the storm, can actually make your storm more tornadic. So like I said, we can't keep it easy. It's got to be some added wrinkle. And then, because Kansas weather can sometimes hate us, there's one other little feature that can get us from multiple different kinds of storms, and that's called a microburst or a downburst. Anybody ever tangled with one of those, or had a roof or a chicken coop or a fence that tangled with it? Yeah?
Cold storage.
Oh, yeah, you had a big downburst on it?
Right now, it just blew everything out. You got the roof.
Those people, yeah, those people that have been hit by a microburst will sometimes swear up one side and down the other. It's tornado, sounded like a tornado, looked like a tornado, created damage like a tornado, but a microburst is not a tornado. First of all, it's not spinning. Actually, what a microburst is, it is strong straight line winds. However, instead of going this way, they're going this way, right down on top of you. For whatever reason, the storm just decided to go whoomp, right on you. And so microburst winds can cause a lot of what looks like tornadic damage because it'll just scatter your roof everywhere. But it is strong straight line winds. But you know, who's going to squabble? You get a new roof out of it either way. These winds can get as high as a low-end tornado. You can have microburst winds that get up in the range of like 100 miles per hour. So they can be dangerous. This is obviously sped up, but there's one in process. It just dumps straight down on you. They may be dry, they have just wind in them, or they could be wet, meaning they have rain in them too. So then you get clobbered with wind and rain. And as they hit the ground, you'll kind of notice that they make a little curl up sort of motion, like this, because they hit so hard. And they actually will call that, with a wet one, they'll call it a rain foot. And with a dry one, since it just poofs the dust up, it'll call it a dust foot. But yeah, it's just straight line wind. All right, we've been going about think we've been going about an hour. So why don't you guys, if the bosses at B are okay, can everybody take a stretch and stretch some legs, go to the restroom, take about 5 minutes? Okay. Make sure it works. He says I'm finding all the bugs for him today. 1 second while we get the sound back up again. All right, now can you hear me? Okay, ready to keep rolling? Anybody got a neighbor that didn't come back that we need to go round up or publicly mock or anything like that? Or okay, well, let's continue. We've got a little sidebar here where we're just going to talk about an instance where actually Chance Hayes, who, if you don't know him, is the warning coordination meteorologist at the Wichita National Weather Service office, but is actually also a Butler County resident. He lives in El Dorado. And he has a little snippet in here about how he used radar to try to protect his paint job last year while some storms were moving through. So in this example, he was trying to get home to El Dorado. He was heading up Highway 77, I believe, is the route he was taking. And he noticed off in the distance some rather nasty-looking dark and ominous clouds. And knowing what he knows about weather, he realized he was probably dealing with a supercell thunderstorm, probably dealing with some hail, that kind of thing. Looking on radar, yeah, there was a blob of really dark stuff moving in on El Dorado, so he was afraid, timing-wise, he was going to show up right about the time the hail was going to land. So he made a fast move south away from the storm, watching it on radar, thinking, okay, I'll just let this puppy pass me by, then I'll safely go back home again. Well, right behind it, another storm generates up, because Kansas is really good about that. You get the storm, you think you're clear, and then they just keep redeveloping. So another one generates right behind it. So here's the original storm. Now this one, if you don't know about hail cores on radar, what these really, really, really concentrated grayish-white cores mean is that those are possibility of really extremely heavy hail, or either heavy or large. One or the other, the radar's catching something. And actually, these little circles here were reports of hail dropping. So he's looking at this going, hey, now wait a minute. Original storm's already passed. I've got a little bit of time till this next storm moves in, so I'm just going to split the difference and race for home. Nice use of radar, right? If you are going to be playing it really close like that, there's some things that you need to keep in mind. And the most important thing is to remember that the radar image you're looking at may not be 100% real time. Now, I don't recall the end result of this story, if he did save his paint job or not. I'll have to ask him next time I see him. But sometimes you can be staring at a radar image and go, okay, I got time, I don't have to shelter yet, I don't have to put the car away yet, I don't have to pull the dog in from outside yet, because it looks like it's still a few miles away, and then the radar goes, boop, and it updates, and it's right over top of you. Just keep that in mind, and maybe use a combination of your radar image, your eyes on the storm, all those other senses, and just make sure what you're seeing on radar is really true to life.
Isn't there a site out there that's real-time radar?
It's, because unfortunately, the radar has to do all of its slices, because it does slices through the atmosphere like this, and then it comes back around and does it like this. So I know the dual pole out of Wichita, there is going to always be a very slight delay. They speed that thing up during severe weather so that it's slicing really rapidly. You've got like about a 1 or 2 minute lag time usually. During clear air mode, when there's not storms going on, you may see that update time extends out. It might be 3 minutes, 4 minutes, depending on your radar source. During storms, though, they tend to speed those up so they cycle really fast, but you still may see a 1 to 2 minute lag as it updates with that fresh radar sweep. Another thing to keep in mind if you're dealing with radar and you're dealing with live eyes on the storm is that a combination of the two is usually your best bet. Because even with real live eyes on the storm, where you are in relation to the storm can make a difference on what you actually see with your eyes. It's kind of hard to make out again with the lighting, but if you look at these 4 pictures, those are all views of the exact same storm, of that storm on radar there. The thing is, it's looking at it from 4 different angles. How different is the information you're getting staring at the storm? It's pretty substantially different, isn't it? One, it's like, oh, it's just a big blob of dark. A couple of them, you've got a really fairly good view of either a funnel in that case or what looks like a tornado here. This one, you could see a really substantial wall cloud. Can't really make out a tornado, but that is all the exact same storm at the exact same moment, just looking at it from 4 different angles. And if you think about it, it kind of makes sense. If you're trying to make out a tornado, and the way you're standing, the tornado is silhouetted against rain and hail, well, a gray tornado and gray rain and hail, they really could kind of blend together, couldn't they? But if you're looking at it with the rain and hail a little more behind you, and the tornado is silhouetted against bright, clear sky, you're going to have a lot more detail, aren't you? But you also have to balance that with keeping yourself in a safe position, too, because you probably don't want to get between the rain and the hail and the tornado, because if the rain and hail is directly behind you and the tornado's in front of you, which way is that tornado probably going? Yeah, right at you. So keep your safety in mind, too. But just remember, perspective makes a huge difference when you're dealing with weather. And then also keeping in mind that whole thing of if you are dealing with radar imagery, you're also dealing with your distance from the radar. So normally here in Andover, we're in good distance from the radar. We should get some really clear radar image. But if you decide to go camping 2 hours that away, maybe you're not going to have the same radar vantage. So this one, where it's shooting at 55 miles up into the storm, kind of looks sort of blobby. Maybe not the detail we saw in that classic supercell picture. This one, you're starting to see kind of that hook look and more of a rain area, rain-free area, because this one's only shooting 37 miles up into the storm. So keep all that in mind as you're looking at a storm, as you're looking at radar. And remembering there's a lot of factors at play. You're not always going to get the 100% ideal picture on radar, but given where you are in relation to the storm, your eyes may not give you 100% of the story either. And one thing to look out for as well, that we really caution against, is when you have a storm that is producing extremely high rainfall rates. What can happen, especially if you have a really big storm that's got itself all cranked up and that thing is spinning, and you're thinking, okay, it's a supercell though. Supercells have rain-free areas and they have rain areas. So rain-free, it's nice and clear, I can see that tornado dropping. But no, now we got this high precipitation supercell that's dropping buckets and buckets and buckets of rain, and it's rotating, and we've got lots of warm, moist air, lots of inflow into the storm, and suddenly all those factors combine, and some of that super heavy rain out front starts to get pulled back into the rotation of the storm, and it creates a nice little rain curtain all around that rain-free base. Suddenly our rain-free base is not rain-free. And if you've got a curtain of rain surrounding the bottom of that updraft column, are you going to see the tornado when it drops? No. Those yellow lines indicate where the tornado is in that picture. If the yellow lines weren't there, would you see the tornado in that picture? You wouldn't, no. Because unfortunately, it's completely hidden in the rain right now. So be really careful. If your gut tells you everything I've heard is that today could be a bad tornadic day, and I can see on radar that that thing looks like a massive wrapped up supercell, and I see this big wall of rain, dark skies ahead of me, I'm not going to plunge into it and just say, oh, it's probably just rain, right? Please? At least nod. Make me feel good. Okay? Yeah, because there is a risk when you have those really high precipitation storms that if it's also a a potentially tornadic storm, that tornado could be lurking in that rain. So we're going to look at a very specific case, a very specific storm that really hammers home the message the Weather Service is trying to communicate this year, which is eyes on a storm. Those people on the ground, that ground truth information is so incredibly important. And anybody want to take a stab at which storm we're going to be talking about? It's one from last year. The Eureka storm. So if any of you recall June 26th of last year, it was rather a busy weather day. It was a very busy weather day here in Butler County. There had been a lot of information, forecast information, coming out saying it could be an extremely active weather day. We were kind of poised for there could be severe thunderstorms. Now, if I recall right, a little activity had brewed up in the morning. We thought, well, maybe that's it. Maybe that's our severe weather for the day. Maybe we're done. Because by about 3 o'clock in the afternoon, it was beautiful, it was clear, there wasn't a cloud in the sky, there wasn't a spot on the radar. We're like, yeah, we're good. We might have skated by this one. And then at about, I was thinking it was between 5 and 6. I remember taking a glance at the radar, and there was a little dot that formed up by Harvey County. And the dot went boop, 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 and then it was moving into our county. And suddenly, it was not a fun day anymore. And if you recall, we had a lot of activity going on, especially northwest of El Dorado, kind of that 196 and 30th area. We were keeping our spotters really busy. There was a lot of activity, a lot of rotating wall clouds, a lot of funnel clouds. We actually had some tornado sightings. So there was a lot of stuff going on here in Butler County. And not saying that we were distracting the Weather Service or anything, but we had a lot of stuff going on here. We had some pretty serious storms going on. So they were definitely putting a lot of attention into watching our storms. And at the same time, at about 7 o'clock that night, some storms started developing over by Greenwood County area too, over by Eureka. And the Weather Service said, oh, there's some storms developing over there. Looks like they could have some severe potential. Back here in Butler County, we've got a lot going on, so we got all those storms up by El Dorado. Now we had some forming north of El Dorado. We had some forming down between Andover and Rose Hill. Eventually dropped a tornado by Gordon. So lots of stuff was going on. But there's a severe storm over there. Well, what they're seeing, just to back up. Can't quite see it right here, but you've got some light. Do you see a bright green there and a little dark red down there that are right side by side of each other? That is a view of the radar called base velocity. So your base radar view or your base reflectivity view says, I'm going to shoot out a radar beam. It's going to bounce off of stuff, and however much stuff it hits is going to produce a color on my radar. Well, in this other view, it says my radar beam went out and it bounced into something. How fast was that something moving? And that gives us some idea of wind speeds. Now, if it's green, it means the stuff is moving toward the radar. If it's red, it means the stuff is moving away from the radar. And if you've got green right next to red, it's doing this, what motion do you suppose that is? It's actually this, isn't it? Yeah, something's rotating. So they saw some rotation because we got green next to red, but it's kind of spread apart. It's not really tight up against each other. So they said, yeah, looks like a supercell is forming. Looks like it may be a rotating supercell, but it's just broad storm rotation. Yeah, not really anything to worry about yet. And this is kind of what the storm was doing as you glanced at it. Well, it's a storm. A little clutter underneath it. You can see a little bit inflow stuff going up into the storm, but see anything that really gives you a chill in the pit of your stomach? Not really at the moment, do you? Well, a few minutes later, definitely still see that broad storm rotation. And the National Weather Service looking at it is thinking, okay, it's a blob. It doesn't have that nice supercell look, that nice hook echo like we saw earlier on that classic supercell image. Probably just going to be severe, probably going to be severe wind, severe hail. That's the kind of thing we're probably expecting. So that's what they went ahead and went with. At 7:07, they issued a severe thunderstorm warning. And if you look at the hazards, it says golf ball-sized hail and 70-mile-per-hour wind gusts. So, higher end severe storm, golf balls, they can do a little damage, 70-mile-per-hour winds, but nothing noted in here saying tornadic potential. Sometimes now with the new Weather Service warnings, they have the option of putting in what's called a tornado tag. So it may say, oh, and tornadoes possible. Just to kind of cover those low-end ones that might pop up in what's not a 100% tornadic environment, but you know, Mother Nature doesn't play by the rules and she might spin something up. That wasn't even in here. It was just wind and hail. Now keep in mind that whole radar distance thing again. So if you look at Eureka, they're not nearly in as prime a position as Andover, right? So they're clear out here. 5,500 feet up into the storm is where we're hitting. So slicing into the storm up here rather than way down here. So that might have had something to do with kind of obscuring what was going on in that storm. It just looks like a blob. Well, maybe it just looks like a blob because they're quite a ways from the radar site. So really definitely spotters were going to play a big role in this storm. Well, this is now about 8 minutes later. They were noticing maybe some collapsing winds out of the storm. Okay, so wind risk might be increasing. Still got some rotation. It maybe is a little bit tighter, but still nothing that to the Weather Service's viewpoint was screaming tornado. So they're still just letting the severe thunderstorm warning carry on. Well, another 4 minutes later was when those pictures were taken by spotters in the Eureka area. Still a severe thunderstorm warning at this point. What does your gut tell you? Now remember, this is what eyes on the storm are seeing, which is not translating to what the radar is seeing. Another minute later, it still pretty much just looks like a blob. It's got some rotation, but it's a blob. This right here, looking from inside Eureka, is actually the massive wall cloud or kind of funnel look that people were starting to see. We get a much better view of it here in a second, though. Fortunately, there was a lot of dash cam coverage, or a lot of dash cams that caught the storm in action. So we're going to kind of see what they were seeing about 7:15 as they were driving around the city. What do you see right here? Kind of look like, if nothing else, I mean, it's kind of hard to see what's happening behind the tree line, but nothing else that looks like a funnel cloud, right? Starting to get nervous yet? Well, they had people that had eyes on the storm that were starting to see these funnel clouds, that were starting to see what looked like a possible touchdown. There was a little bit of an issue getting that information communicated to the National Weather Service. They were having some comms issues at the time. So they were seeing stuff, but it couldn't get relayed right away. Finally, they were able to tell the Weather Service at 7:17, hey, guys, not just severe. We think we've got funnel clouds. We think we may have tornadoes moving into our town. And so National Weather Service is like, okay, well, we'll start working on a tornado warning. What you're seeing here, that rushing wind, is actually inflow winds. That storm is sucking up fuel into it so fast and so hard, it's actually creating those sheets moving across the road there. That's actually inflow going into the storm. 7:17, they have a report of a funnel. We're still in this. At this point, there's just a severe thunderstorm warning on this storm. So this next video, it's somebody from the east side of town looking to the west. So at that point, still just a severe thunderstorm warning. Normally in most communities, it's a tornado warning that will trigger the sirens to be sounded. By that point, the community was going, no. Based on what we're seeing, we're sounding our sirens. So another dash cam, somebody moving toward the funnel, possibly tornado, not realizing at first that's what they were heading toward, realizing that maybe this is a bad idea, and doing a little bit of a course correction here. cops here. I'm sure Chief doesn't mind you getting this close to get some quality spotting in. Don't worry about that, right?
Nobody's more surprised than I.
Exactly.
On a dark and stormy night.
So you don't see the funnel or the tornado itself in this picture, but you definitely see the effects of it, don't you? We've got some serious winds going on. Okay, this is 7:18 p.m., so a minute later. So we've got reports were finally rolling to the Weather Service just 3 or 4 minutes ago. Tornado sirens have already been sounded, but it's still just a severe thunderstorm warning at this point. Here's another person that's looking. So if their vantage point is this way, it means this thing's already into the city. And that's actually looking from the courthouse, I believe. What you will see eventually here is you're going to see a darkness form here that is actually the tornado. It isn't the best video, but watch for that shading to show up. You can see little bits of debris flying. All right, can you see it darkening up over there? Yeah, that is the tornado actually moving in through the city. And then finally, stars have all aligned. We have a tornado warning issued for central Greenwood County. At 7:19, a severe thunderstorm capable of producing a tornado was located over Eureka, moving east at 10 miles per hour. The hazards, tornadoes and golf ball-sized hail. Had this community waited until they had an official warning from the Weather Service to take any action, to recommend sheltering, to sound their sirens, would it have been too late? Absolutely. So at that point, it wasn't the Weather Service, feed us with information, tell us what to do. It was the people with eyes on the ground that were looking up at the storm going, guys, we're in trouble. We got to do something. Making those decisions to sound sirens, realizing that what they were actually seeing live and in person was a better story than what the Weather Service was seeing on their radar at that point. And so now here at 7:20, about a minute after the tornado warning was issued, finally they're seeing the definition on radar that would really cause them to pull the trigger. Because remember, up till this point, there is nothing on that radar imagery that's screaming, we've got a tornado going on. So we've still got kind of a blob of a storm. There's a little bit of a notch area here that says maybe that's that area of the storm we need to worry about. And finally, you got that really tight, bright green, bright red side by side that says, tight, 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 tight rotation. Maybe that's a tornado. So the radar did not catch up with the story until well past the time where people needed to take action. So in this case, again, eyes on the storm is what saved people. One more shot looking at the storm in action. And that is a tornado in the city of Eureka actively doing damage. When all was said and done and they did their survey of the damage, rated the tornado, at its peak, it was given a rating of an EF3. Now, if you actually will look at a tornado track, you'll always hear a tornado rated as EF2, EF3, EF4. That is at its peak damage. But if you actually look at a tornado's path, like if you pulled up the Andover tornado's path, it doesn't say EF5. Actually, back then it was before the enhanced scale, so it'd say F5. It doesn't say F5 all the way across. It might say F1, F2, F3, F4, F2, F3. You'll see it actually change. So they always record it at its peak damage. At its peak, the Eureka tornado was doing EF3 level damage, which means that the peak winds were estimated at 152 miles per hour. When it was first published, the length of the tornado was only recorded, I believe, at a couple miles. But I noticed when I pulled the most recent survey off the Weather Service website, they were giving it credit for over 8 miles, and the path was showing it extending out into the country. Still, the part that did the damage was really the part in town. They estimate the maximum width at about 500 yards, and unlike the tornado 2 years before that one in 2016, which had no injuries, no fatalities, this one did actually produce 8 injuries. Still no fatalities, fortunately. What would that number have looked like if people hadn't taken action until they got a warning? until the Weather Service said, go do. Probably a whole lot higher, right? Yeah, using that ground truth information and what they were seeing and using that information to take action kept that number as low as it was. So again, kind of rehashing that whole why it's so important of putting the two together, not just relying on the Weather Service, not just relying on radar, but also not just relying on what you see live and in person, but putting those two pieces together. So we've got a nice storm here. Got some blobs, got a little bright spot that says maybe some hail if you're looking just at radar. Now the Weather Service has some really cool tools. They can turn their radar up and make it 3D and slice through the storm and go, ooh, look, we got a really big updraft. We got some dots that say, hey, we probably got some hail falling. Remember, this is a probably. It looks like it may be producing. And then the guy out in the field says, hey, here's my picture. Here's what I'm seeing. Yeah, that looks like hail, doesn't it? That'll put a little knot on your head. And oh, there's a lot of it covering the ground. It's like coming down in sheets of hail. Important information that they need to know. Squall lines. What was our hazard again with squall lines? Strong straight line winds. So the Weather Service may look at that radar image, or you may look at the radar image and go, yeah, I know a squall line could potentially produce strong straight line winds. And you know, this one actually may be starting to bow a little bit right here at the center, so maybe even stronger straight line winds right there. And somebody out in the field may say, oh, yeah, look, hey, got a really impressive shelf cloud. This is definitely a squall line. And then somebody else might say, yeah, and that's my house. So really big proof that, I mean, that's a substantial tree that got uprooted. Now, in this case, that actually is the National Weather Service office in Wichita. If you've never been down there, that's down on Tyler Road. That's the nice little ball for their radar. In that case, you would think, well, maybe they don't need spotters because they can just look out the window and go, yeah, that's a really lovely supercell thunderstorm. I can see it on radar. I can see it's got a lot of rotation. I see big updraft. I see really nice, big, well-formed anvil. So they don't need us, right? Yeah, but remember that when you can see that kind of definition and you can see your anvil and all that, you're miles from the storm. You're looking at it from a distance. So somebody looking at the underside of it may be able to give them a little more information about the rotation, about whether or not there's any wall clouds, whether there's any funnel clouds or tornadoes. Okay, that one's probably photoshopped. But if there's any tornadoes with guys out mowing, and maybe that picture, you know, one of the pictures from Eureka letting them know, yes, there was a tornado on the ground. So, last thing we have to do before you guys are done is we have to talk about just those general weather safety tips. Before we go into general weather safety, any questions from what we talked about so far or from the case study? You guys ready to get this last bit out of the way? All right. Somebody's cheering. Somebody's really excited to go home. So weather safety-wise, one of the most important things that, whoops, definitely can't miss this guy. One of the most important things is be prepared in that you need to be aware of what the potential is before the weather even arrives. So maybe plan your run for a time when it's not going to be hailing. And I don't know why his buddy's following him, filming him running out in the hail, but before the storm even arrives, be ready for it. Know what kind of weather you're going to be anticipating. Know what the environment's like. If you get into a situation where you need to take action, do it quickly. Don't do it after this next round, after this next inning, after the burgers are done. And basically comes down to use your common sense. In Kansas, we're used to severe weather. We maybe are a little more casual with our severe weather, but we also don't want to be so casual and laid back to the point we get ourselves burned. Now, one of the things that's unfortunate is flooding is still one of the leading causes of severe weather-related deaths. And what it comes down to is a lot of people underestimate how serious floodwaters actually are, because a lot of times it just looks like it's some water over the road. And you can't necessarily see how fast is it moving, how deep is it, how much of the road is already eroded away. So to try to help you understand it this time, the National Weather Service actually compared floodwaters to wind speeds. Because if you've got a lot of really rapidly moving floodwater, a lot of water, it's got a lot of force behind it. So if you take swiftly moving floodwater going at 4 miles per hour, the force that that is exerting when it slams into you is the equivalent of an EF2 tornado. That's quite a bit of force, right? Now let's speed that floodwater up. Let's make it a 7 mile per hour water flow. That's like an EF5 tornado, greater than 200 miles per hour. So that water is going to relocate a few things, isn't it? 10 mile per hour water flow is greater than 270 miles per hour. And if you actually got water, flood water's moving at 25 miles per hour, well, that's essentially faster than the speed of sound. So while it may look like just water, there is a lot of force behind that just water. Water's covering the road. You know the road was there this morning. You took that route this morning. It rained quite a bit since you've been home. Is it safe to go through it, or should we go around it? Well, if you've got a hover round, go for it. Anything else, go around. Because apparently those suckers will go through anything. All right, but what if the car in front of you made it? Does that mean it's okay to go? Well, in that case, you're just following the herd, and following the herd can sometimes end badly as well. Yes, that apparently is actually a herd of cattle washing downstream. And you got to look at how fast they're moving. Now you hear those numbers. 6 feet or 6 inches of water will knock a person off their feet. 2 feet of water will float a vehicle. Well, sometimes it's not just the whether or not your vehicle floats. It could be whether or not your vehicle stalls, because the water may not be at the deepest point yet. So if you drive into the water and your vehicle stalls and the water's still rising, you may not be totally in trouble yet, but in a matter of a very few short minutes, you could be in a whole lot of trouble. So keep that in mind, that water will float you. And it doesn't matter if you're in a car, if you're in an F-150, if you're in a fire truck, don't float your fire truck. Or in this case, if you're in a school bus. And the information of where this came from wasn't included with the slides, so I went and looked it up. And apparently this was an incident that happened, I think, last October down in Texas. This is not a simulation. It wasn't a training event. This was actually a school bus driver, and that was a barrier sign, don't go around this sign. Had one student on board, was apparently taking that student home, went around the road closed sign, and thought that that was passable.
Oh, you went too slow. You can do it. You can do it. I don't want to.
Yeah, so especially if it's deep enough that it's going to wash over your hood, probably should not be out in it. And he does continue to float downstream. Eventually got caught up on some trees and some debris and did come to a stop. They had to do a water rescue. He had, I believe it was a 12-year-old student with him. Both he and the 12-year-old student were safely rescued. Not only did he lose his job as a bus driver, as you would expect, he actually has been brought up on criminal charges, I believe, for child endangerment.
12-year-old is rich.
Yeah. Now, like I mentioned earlier, the road was there this morning, right? So the road is surely still there this evening, even with the floodwater washing over it. Well, not necessarily, and apparently Greenwood County was having a really bad weather year because this picture came out of Greenwood County. But if this still had floodwaters rushing through here, now it's low enough you can see the road is missing. But if the floodwaters were still rushing through and you saw pavement here and pavement here and made the assumption there was still pavement in between, could you have gotten yourself in a little bit of trouble? Yeah. Because obviously the water was moving with enough force that it actually completely took out that road. And it may be it'll just erode away a corner of the road, or it may be it takes out the whole road. But either way, it's going to end badly for you probably. And also another thing about floodwaters is it tends to kind of obscure landmarks. So it may be that you make this turn every single day, but when the intersection's underwater, maybe the intersection doesn't look quite the same. So you think you've gone as far as the intersection and you're turning into it, but maybe you're actually turning into the ditch beside it because you haven't gone quite far enough because it doesn't look the same covered in water. So yeah, just don't take the risk. How about lightning? How do we feel about lightning? In that case, it wasn't just the lightning that was the problem, was it? So what the lightning hit and knocked down on you is also a problem as well. Well, one of the concerns with lightning, obviously, is that it does hit stuff. It does like to aim for the tallest thing, but that's not necessarily what it's going to go for. But when you have lightning with a storm, one thing to think about is that lightning is kind of a solo act. He doesn't necessarily like to hang out with the rest of the storm. Sometimes he'll go on ahead of the storm, and he'll smack you before the storm shows up. So lightning can get you. You'll see a little difference in numbers if you look on the internet. NWS estimates that lightning can get you about 10 miles ahead of the body of the storm. I've heard other folks estimate even further than that. So you could be sitting under a completely blue sky day and think, yeah, storm's in the distance, I'm fine. But you can see the flash, and maybe you can see the flash and you can hear the crash. If you've got both of those going on, you can be hit by lightning. So we got these folks here that maybe aren't following their visual cues. That seems awful close, doesn't it? But you know it's not raining there yet. It's still clear. So the band plays on. And just a short time later, another minute later, another lightning strike, seeming dangerously close, but the band plays on. Because surely that storm's still a long ways away. About 30 seconds later, yeah, is that far enough away that we don't have to worry about it yet? No. The sad thing is you got like 2 or 3 people that are like, whoa, running away, and everybody else is still enjoying the show. Sort of slow reaction time there. So yeah, lightning, don't mess with lightning. Get indoors. All right, now for the tornado safety portion of it, we've got a video here that was actually put together by the Weather Channel. I'm hoping you'll be able to hear him okay. But what they're going to do is they're going to step through that EF0 all the way up to EF5 in a simulated fashion. I will tell you these aren't real tornadoes, just in case you were unsure once it starts.
Let's take a look outside. Trouble is already brewing. We've got a tornado warning for that cell right there. Bam! It hits the same place. The right supersonic pulse. A rotating thunderstorm is a supersonic. Not all of them are destroyed, but this one's got a chance. We're watching this base. It's lowering. Almost looks like there's a funnel starting over here across the wall front. Yes, there it is. Do we have debris on the ground? Yes, we do. There's a debris cloud. A connection.
So kind of a clever little way to step through the intensity levels and the wind speeds of our tornadoes. Now, really, it comes down to one takeaway from that whole thing, and that is, what is the safest way to shelter from the tornadoes? Obviously, we want you to get as low as possible. So if you have a basement option or a storm cellar option, that's always a direction we want you to err toward. But not everybody has a basement option or a cellar option. But that doesn't mean that you can't safely ride out a tornadic storm. What we want you to do, if you are in a well-built, stick-built building, now the rules are totally different if you're in a mobile home, one of your tin-out buildings doing some, work on the car or something. Those do not ride out storms. So you're going to want to make sure that you have a way to get to shelter ahead of the storm if you're going to be in one of those during a storm. If you're in a well-built, stick-built building, though, what you want to aim for is getting to as low a level as possible and as interior as possible. So we're talking first floor, and then you want to try to put walls between you and the storm. So if you have an interior bathroom, an interior closet, somewhere where you could get hunkered down, even if you can't get below ground, you can ride out the majority of the tornadoes we see around here. Now, we do have a history of sometimes getting those massive EF5 tornadoes, and they will completely clear off a foundation. But those EF4s, EF5s, statistically happen less than 5% of the time. So if 95+% of the time we have tornadoes that cannot get all the way through every layer of your house, you're actually going to be all right riding it out in that interior room. So most of the time, and if you remember back to that map that showed the history of Butler County's tornadoes, what did we get most of the time? You have zeros, you have ones. Yeah, you're definitely, even if you're on a first floor and not in the basement, going to be able to ride those out. But remember, grab your helmet too, if you heard him say that. So keep your helmet in your emergency kit. If you really enjoy the science portion of it and you want to know more about the science behind the storm, all that meteorological stuff, maybe not the duodecillions and the tritodecillions and all that kind of stuff, but a little more of what is that mechanics of what's going on inside of a storm, this is one of those years where the National Weather Service is actually offering their advanced storm spotter classes. They only do those about every 2 to 3 to 4 years, and this is one of those years where they will be offering it. The one that's closest to us is going to be April 4th. It's over at Wilbur Middle School in Wichita. That's way over in West Wichita. It's the middle school that's over on Tyler Road. If you're interested in attending that, I have been cautioned that those are extremely well attended and people show up really early. So if you want to go to that one and you want to actually have a place to sit, I wouldn't arrive at 6:25, maybe a little ahead of that. So that is at 6:30 on April 4th, and then there's other options too if you can't do the April 4th. But that is the end of your severe weather training for this year. We did get done before 5 o'clock. We got a little time for questions if you guys have any. Otherwise, if you want to just make a mad dash for the door, you are now free to make a mad dash for the door.